Well, hi everyone, this is Bob the Science Guy, and today we're going to continue working on Chapter 1 physics problems from University Physics on OpenStax. Now, in this episode, we're going to be converting units within a unit. So, for example, we're going to convert meters to kilometers or kilometers to miles. So our first question is number 25, and it has to do with time. So here the following times are given in seconds. Use metric prefixes to rewrite them so that the numerical value is greater than 1 but less than 1,000. And then it gives a quick example. So if we go back to page 17, we see these prefixes for metric units. Once again, I don't know of anybody that's ever reported something in Yotta years or Yotta seconds, but let's go ahead and go through this real quick. So our first question is 9.57 times 10 to the 5 seconds. So the easiest way to do this is do it on a number line. So this number is well above 0, so we're going to put 0 here. And we're going to look for a couple of prefixes out in this general area that would fit this range. Well, let's see now. 10 to the 3 would be kilo. And then 10 to the 6 would be mega. Now, our value is actually right about here. So our value is about right here. So since the requirement is that we have to come up with an answer between 1 and 1,000, we're going to be in kiloseconds. And what is that going to be? Well, so we have 10 to the 5 in our units here, and we're going to subtract from that 10 to the 3, and we're going to end up with 10 to the 2. So this is going to be in the hundreds. So our answer is going to be 957 kiloseconds. And finally, we've got 3.6 times 10 to the 7th. So once again, we're going to have our number line here. 0 is going to be over here because that's positive. So we're going to have a 10 to the 6th here, and we're going to have a 10 to the 9th here. Okay, so a 10 to the 6th would be a megasecond, and a 10 to the 9th would be a gigasecond. So since we are actually located out here, we're still in the megasecond range, and we're not quite out to the gigasecond. So by how much? Well, 10 to the 6th, 10 to the 7th minus 10 to the 6th equals 10 to the 1. So we're going to have 31.6 megaseconds. Now the next calculation is just a little bit tedious, but it's actually pretty easy to do. It's number 30. Now we're given that the Earth's volume is roughly 10 times 21 meters cubed, and they want to know what is that in kilometers. Well, let's go ahead and draw a quick diagram. A cubic kilometer is a cube 1,000 meters by 1,000 meters by 1,000 meters. So we've got 10 to the 3, and then we're going to cube it with 3. Now when you raise an exponent to an exponent, you multiply them, so that ends up as 10 to the 9th. So 10 to the 21 divided by 10 to the 9th means that we take 21 and subtract 9 from it, and we get 10 to the 12th cubic kilometers. Pretty straightforward. Next, we need to convert cubic kilometers to miles. So we've got 10 to the 12th cubic kilometers. How many square miles, or how many cubic miles is that? Once again, draw a little diagram. There's 1.62 kilometers per mile. And when we cube that, we find that for every cubic mile, there is 4.25 cubic kilometers. Then it's just a simple matter of taking 1 times 10 to the 12th cubic kilometers and dividing it by 4.25. What's that come out to? 0.235 times 10 to the 12th miles cubed. But we want to get rid of that decimal place, so we have to shift it over 1. And as a result, we get 2.35 times 10 to the 11th cubic miles. And finally, ultimately ridiculous, they want to know in cubic centimeters. Well, we can do that. The Earth's volume is approximately 10 to the 21 meters cubed. So let's take a cubic meter. How many centimeters are in a meter? Well, 100. So that would be 100 times 100 times 100, 10 to the 2 raised to the power of 3 gives us 10 to the 6. All we have to do is multiply 10 to the 21 by 10 to the 6, and we end up with 10 to the 27th cubic centimeters. Now we get a little bit of a break. Problem number 31 is pretty straightforward, and it's also quite common. Okay, now this next one can actually be just a little bit tricky. It's a conversion between miles per hour and kilometers per hour. So we normally abbreviate kilometers per hour and miles per hour like so, as if they're all one variable. In reality, they're like this. It's 100 kilometers over an hour. So in order to do the conversion, we'll take 100 kilometers, here, like that, in 1 hour, times how many kilometers per mile. Okay, so 1 mile, 1.62 kilometers. And what's this going to spit out our answer in? Well, the kilometers will cancel, and we'll get miles per hour. And it equals 61.7 miles per hour. Okay, next one. How many meters per second is that? Let's do it again. So we have a speed of 100 kilometers per hour. How many minutes per hour? 60. Okay. So now our hours will cancel out, and we'll get kilometers per minute. And then finally, we want to multiply, well, not quite finally, but now we want to go with 1 minute equals 60 seconds, because they want our answer in meters per second. And then finally, we have to get rid of this kilometers. So we got to get 1,000 meters in 1 kilometer. Okay, so what happens here? Hours cancel, minutes cancel, kilometers cancel, and what do we end up with? We end up with meters per second. So let's go ahead and do the math real quick. 27.7 meters per second. And there we go. Now again, the next one's pretty easy too. That's 37. And it says that Mount Everest is 29,028 feet high. How many meters is that? Now, what the book says is that there are 3.281 feet per meter. So all we do is we take 29,028 feet divided by 3.281 divided by 3.281. Okay, we've got about, and that equals 8,847 meters. So how many meters are there in a kilometer? Well, there's 1,000 meters in 1 kilometer. So that equals 8.847 kilometers. And there's our answer. Pretty straightforward. Okay, 42 says the density of aluminum is 2.7 grams per centimeter squared, or centimeter cubed, excuse me. And it wants to know, what is the density in kilograms per cubic meter? Well, what's our first step? Obviously, let's draw a picture. Okay, so here's our meter. That means that we have 100 centimeters on a side. So that equals 10 to the 2 cubed equals 10 to the 6 cubic centimeters. Our density here is given grams per cubic centimeter, so we can always, there's obviously a shortcut to do this, but I'm trying to do every step along the way. So we take 2.7 times 10 to the 6th, and that equals the density of aluminum, 2.7 million grams per cubic meter. Okay, but it doesn't want it in grams, it wants it in kilograms. So how many grams are in a kilogram? Well, there are 1,000 or 10 to the 3 grams in a kilogram. So it's going to be 2.7 2.7 times 10 to the 6th divided by 10 to the 3 equals 2.7 times 10 to the 3 kilograms. And there's our answer. Now in the next episode, we're going to go over dimensions and looking to see whether or not things have common dimensions in equations. It should be pretty straightforward, very simple to do. I'll see you then. Take care.